We're going to be doing the physics for week 9 AMS. It's really easy this week. It's just one formula or like few formulas, but they're all related, so they're really easy to memorize. Let's start. So which of the following are properties of electromagnets? To be fair, I don't know where this question came from. We didn't take it, but it's really easy. An electromagnet is a magnet that's made out of a copper rod, or like made out of a metal that has a copper rod wrapped around it like that, or spiraled around it, that when you put a current through this rod, it's gonna be magnetizing, and when you stop the current, it stops magnetizing. So electromagnetics are made by winding a current carrying wire around an insulating one. It's the opposite. And there's no insulating core. It's not an insulating core. It's a conducting core that you're putting a current through, and you're like twisting a wire around it. Now, so this one is wrong. Electromagnets are permanent magnets of fixed strength. No, they're not permanent. Like I said, they're only magnetizing when you get when you put a current through it. Electromagnets stop being magnetized when current through them is off. This is true. They don't magnetize when the current is off. The role of an electromagnet's core is to increase the magnetic field strength. Yeah, this core inside here is to increase the strength, because more current equals more strength equals what, it's stronger magnetization. So the direction of the electromagnet's magnetic field can be changed by will. Yes, because it depends on how much current you put into it. That's what's gonna change its magnetizing power. So let's move on to the next one. Now for this question, it's asking you which statements about temperature and sensation of hotness are true. So for this question, we need to read them. A person experiences a sensation of hotness when heat flows into their hands. If it says into, it only makes sense that it'll be heat and hotness. Because when you have energy going into you, or like going into any object, kinetic energy increases, so you'll feel a sensation of hotness. Now, a person experiences a sensation of coldness when heat flows into their hands? No. When heat flows out of your hands, you feel coldness, not into. Now, the temperature is the degree of hotness of a body. Yes, it's the definition of temperature in our books either way. Sensation of hotness can be used to accurately measure temperature? No, you can't. You need sensation of hotness isn't enough to measure temperature. You need actual specific ways. And it's not accurate. You could use it, but it's not accurate. That's why this option is wrong. Sensation of hotness is a quality that can be measured. Not really. That's why we don't say it accurately measures temperature. It can't really be measured. That's why. So let's move on to the next one. Okay. So which of the following hazards are the hazards of calibrating a mercury thermometer? We know mercury is a really, really toxic material. So toxic mercury is of course right. Toxic steam, no, because mercury is a liquid, it won't give off steam. Extreme heat, yes, when mercury is heated, it will become really, really hot. Really hot. So if that gets on you, you're gonna burn. Fragile glassware, yes, because if a mercury tube falls down, instantly it's broken. There's no way of preventing it. Extremely cold, no, not extremely cold, it's extremely hot. And let's move on. Okay. Pressure law. So the fixed amount of gas in a sealed rigid cylinder of volume 10 centimeters cubed is the rigid cylinder of volume 10 centimeters cubed. Initially the gas is at negative 73 and at 800 millimeter Hg. So let's read the first part. In order for the pressure law to be applied on a fixed amount of gas, which of the following quantities must remain constant? So what's the pressure law? The pressure law is where you have volume is constant. When you see pressure law, no volume is constant. Only volume. Because the pressure law is P over T. pressure law is P over T equals constant. And we don't use volume, so volume is our constant here. So this volume isn't gonna change, we don't look at its number. So let's see part B. Okay, if the pressure of the gas becomes 1200 millimeter Hg. So we know it was 800 millimeter Hg, and it was, I forgot, wait, 800 and negative 73. Okay, so like I told you, okay, let me write the numbers down before I forget them, and negative 73 Celsius. Okay, so these were our original values, and we know that the pressure law is, like I just said, P over T1 equals P2 over T2. So let's write P1, which is 800. It has to be absolute temperature. You can't put it in degrees Celsius. So it's negative 73 plus 273, which is your Kelvin thing. You could put plus 0.15, which will give you more accurate answers. Personally, I don't. Equals pressure 2, your new pressure, which is 1200 over T2. Then you're gonna find your answer, cross multiply. Wait, I can't. So let's see. You're gonna do negative 73, I'm gonna do it on my calculator, plus 273. This here is I'm gonna put it as 200 because this is what it is. It's 200. So 200 times 1200 is 24. So you're cross multiplying. So this times this is 2, 4, 1, 2, 3, 4 zeros equals 800 times T. 2. So now you're gonna divide the 800 by this number by the 800. So this divide by 800 is gonna give you T2 equals to 300. But this is in Kelvin. They want it in degrees Celsius. So this value, you minus it by 273, you're gonna get 27 as your degrees Celsius. Now moving on. Okay, here you have Boyle's law. What's Boyle's law? Boyle's law is the law that is where temperature is constant. So it's just PV11 equals PV2 and 2. So let's start. Pressure, it was 200. Volume was 4. Equals new volume is what we're looking for, and the pressure became increased by 300. Read it carefully. It didn't become 300, it increased by 300. So it's 200 plus 300, so it's 500 plus times volume 2. So you're gonna get here 800 and here 500 times V2. So V2 equals 1.6. When you put it in your calculator, you're gonna find it out. So let's move on. Okay, so on the Celsius scale, this is a memorizing question. So what you do is, on the Celsius scale, the ice point, 0 degrees Celsius, steam point, 100 degrees Celsius. We've been taking this since we were kids. This is the new one. Atmospheric pressure is equal to 100 kilopascal. Or they might tell you 1 times 10 power 5 pascals. But memorize both in case they give it to you in any way or form. Okay, so for this question, it's asking us absolute temperature of gas 150. We do 150 plus 273. You could do 0.15, but then that's gonna give you decimals, and we don't want decimals in our answers, so let's not. So when you do this in your calculator, you're gonna get this answer. That's it. Okay, Boyle's law again. For a fixed mass, all of these equations, by the way, all have fixed masses. of an ideal gas, the relation between P and V at a constant temperature T expressed using Boyle's law. We said constant temperature T, then the law is PV equals K. K is a constant, like they give us here. So this memorize. Now let's move on. Okay, like we said, relation between absolute temperature scale Kelvin and Celsius is this. This is your number exactly, 273.15. Let's move on. Charles' law. Charles' law is the law that has what's it called? Pressure constant. So Charles' law is V1 over T1 equals constant, or like if you want to use it in an equation, V2 over T2. I'm sorry. So has a volume of 8 and 27 degrees Celsius. So volume 8 over 27 plus 273, don't forget it, please, is gonna equal to a new volume. We're trying to find this, which is volume V2 over a temperature of 177 Kelvin. Celsius. 177. So it's 177 plus 273. So to do that, you're gonna, when you add them in your calculator, you're gonna get this to be 450 and this to be 300 if I'm not wrong. Wait, let me add it. 27 plus 273. This is 300. So now let's cross multiply. 450 times 8 is gonna give us 3,600. And then divide that by 300. We're gonna get 12. Like, because zeros cancel out, 36 divided by 3 is 12. That's it for this question. Let's move on. Okay. So the pressure inside of a gas container at 40 centimeters of HD at this temperature, and the gas the temperature is dropped to this. Volume is constant, so we're using pressure law here. So 40 pressure law, which is P over T, equals P over T. 40 over 127, I'm just gonna put it in Kelvin directly, plus 273. This is gonna be 400 equals pressure P over negative 73. I think it's just 200. So 200 times 40 divided by 400 should be 20. And that's how you get your answer. Moving on. Okay, these are from old material. So 40 kilograms, 50 stairs, 30 centimeters, and 10. We know that this is W equals mgh. Mass 40 times g 10. H is 50 stairs times 30 centimeters. Is going to give us 150 centimeters divided by 100 to make it in meters, so 1.5. So let's put that into our calculator. 40 times 10 times 1.5. It gives us, no wait, there's something wrong. 40 kilograms. Oh, sorry, this is 1,500 centimeters, so it's gonna be 15. My bad, guys. Wait, let me just make sure. Yeah, sorry. So it's 15, gives you 6,000. In kilojoules, remove 3 zeros, so you're going to be left with 6. That's it. Let's move on. Okay. Thermometric properties are the ones that we just mentioned, the 3 laws. So volume of a fixed amount of gas at a constant pressure. Yes, this is Boyle's law. It's the thermometric property. Mass of fixed amount of gas at a constant pressure. This isn't a thermometric property. It has nothing to do with what we're taking. Hardness of an egg. Personally, I don't know how a person would think this is thermometric. So, obviously not. Length of mercury in a tube. Yes, because mercury is the main thing we use to measure temperatures in the lab. Okay, this is just labeling. At any point here is your steam point. and this is your steam at 100 degrees Celsius, because we know that the steam point is 100 degrees. This is your boiling water, and this is your heat you input. And yeah. Okay. So now next question. It's telling us that you have a fixed amount of gas at a constant temperature of 25 degrees Celsius through a Newton experiment. Initial pressure of gas. Okay, I'm just gonna write this because it's annoying me at this point. This is 298 Kelvin. Gas is 1 atmosphere and its volume is 12, and then the pressure increased to 3 atmosphere. They told us that constant temperature, but still they want to know what's the temperature in Kelvin. This, but it doesn't change. We don't use it in our equation. So now let's see part B. Okay, now part B, to find final volume of the above gas needs to be a Boyle's law, because Boyle's law is the one where temperature is constant. And final, okay, so V over T equals V over T. So about, okay, so let's see the numbers we had. Volume, so you have the volume in this question is, so wait, what? Oh yeah, here volume, you started it off 1 atmosphere over, no wait, sorry, what T? We're not using T, sorry guys. So we just said T is constant. VP, or it's PV, same, PV equals PV, since it's Boyle's law. So 1 times volume, which is 12, equals 3 times something, which when you multiply them, 12 equals 3x, which is x means is 4. So it's 4 centimeters cubed. So next question. Like I said, this entire quiz is the same type of question. Charles' law, pressure and mass. Mass always must remain constant. Charles' law, we said it's the law where we have pressure constant. If the volume of the gas increased to 18 centimeters, okay, so wait, sorry. You had 8 atmospheres and they didn't change because pressure stays same. Volume is 12, temperature 27. So you had 12 over 300 equals 18 over something. So we're gonna do 300 times 18 on our calculators, then you're gonna divide it by 12, which is 450. You're gonna get x equals 450. But let's read the question. They want it in degrees Celsius minus 273. Subtract it from 273, you're gonna get 177. And that's it. Let's move on. Okay, so here, this question, it's a bit tricky, but it's really easy once you understand. So I'm just gonna give it to you like in the easiest way to memorize it, because I don't think they're gonna give you anything like other than quadruples or something like that. When you, here let's read the question. At 300 Kelvin, this is your speed, okay? When the absolute temperature is increased to 1200, which means it quadrupled, if you can see. So it's times 4. When you have your temperature, when your temperature is quadrupling, when temperature is times 4, kinetic energy is times 4, but velocity is times 2. So velocity times 2. Okay? So it's, now let's see. So this quadrupled, so velocity, it's gonna double. That's it. That's all you need to know for this question. Now this part, it's like the same thing almost. So fixed amount of gas is kept at temperature T. Average speed and so temperature was quadrupled. We said that kinetic energy will quadruple, but speed will double. That is it. Let's move on. Okay, for this question, I explained it in the periodic. Let me explain it again. So let's start. So you have this 200 gram bulb, so 0.2 kilogram of a bulb, and its length 0.8 horizontally. We need height because we know that its kinetic energy equals gravitational potential energy at, not at anything actually. So anyways, we're just gonna use them to solve. So you have the horizontal but not the height, which is we need it for GPE, the lowest position. Take G to be 10. Okay, what we do here first is we have to find the kinetic energy to find GPE so we can find the height. Okay, so let's do kinetic energy equals half m, which is 0.2, v squared, which is 2 squared, which is 4. Let's rewrite it. Half 0.2 times 4. So when you put this into your calculator, 0.5 times 0.2 times 4, you're gonna get your answer to equal 0.4. And we know GPE equals kinetic energy, so GPE equals 0.4. What's GPE's formula? It's mgh, right? So 0.4 equals mass 0.2 g times 10 times h. So 0.4 divided by 2 equals 0.2. So your height is 0.2. And for this type of question, you're gonna use a specific equation that we didn't take really. It's maximum angle. When you see this word, you're gonna do 1 minus height, which is 0.2, divided by horizontal length, which is 0.8. So do it on your calculators really quickly. You're gonna get the answer to be 0.75. That is it. Moving on. By the way, if they ask you for the actual angle, you're just gonna do cosine -1 and you're 75, you're gonna get your angle. This question, right hand rule. When you're moving it like this, you're moving counterclockwise, which is out of the plane of the page, which is positive. Just do right hand rule. Now, moving on to the last question. Question about power. So you have a column crane lifts 320 kilograms of 12th floor in 120 seconds. 3.2 meters is each floor and 10 is your head. So to find the height, you multiply floors by meters of each floor. 12 times 3.2. You're gonna get the height was 38.4. Multiplied it by the mass, because it's mgh, 320. We had this in our periodic the other day. Then you multiply it by 10 times 10. You're gonna get 122,880. Then you're gonna divide it by the number of seconds, divide by 120. Do it on your calculators really quick. You're gonna get 1024. That is it for physics. It's all really easy once you know what you're doing. And I hope you have a good day. Bye.